All right, so today what we're going to do is we're going to teach scientific and go over scientific notation. Now, I'm not going to jump right into your packets right away, okay? What I'm going to do is I'm going to teach you the general form of scientific notation first. And then after I teach you the general form of it, we'll do a few examples out of your packet, okay? So here we go. So first of all, scientific notation, what you have to remember is how to write it properly. By far the most important part. And it will take on this form. You'll have something A times 10 to the power of something B. That's the general form that you will see. Now here's the thing about it. This number A must fall between 1.000 infinity, 1, meaning it's got to be what? Greater than or less than 1?
Greater than.
Greater than 1. And it must be less than 9.999999999. So here's what you got to remember. There can only be one number in front of that decimal. So it's got to be 1 point something, 2 point something, 9 point something. It can never be 12 point.
No, why is that?
Because that's scientific notation. The proper way to write it is the first number has to fall in that range. So 0.68 times does not exist. 6.8 does, because that's somewhere in this range. Times 10 to something, the power B. Now, here's what you got to remember. If this is positive, it means move the decimal forward. Okay, when I think about things being positive, I think about moving forward, right? So, if it's positive B, the decimal moves right. If it's negative, the decimal is to the left. The number gets smaller. Let's do some examples right out of your packet. Guys, can you keep me updated on the time? There's a little time clock, right?
2:30.
All right. When we get around 5 minutes, I want to know, because I don't want the videos to be that long. I want it to be like a 5-6 minute video. All right. So here we go. Scientific notation. So everybody, look at that first one. It says 0.00374. Let me get out two colors here. So, in order for this rule, this A, to be kept, where does that decimal have to be moved to?
Between the 3 and the 7.
Does everybody agree with that? Between the 3 and the 7?
Times 10 to the third.
It would have to be right there.
No, negative third.
3.74 is in that range. 0.374 is not. 37.4 is not. Now, hi. So, if you put the decimal right there, here's what you got to ask yourself now. Would you move the decimal left or right to get it back where it belongs? From this pink arrow to where it actually is, you'd move to the left. Therefore, this B is going to be negative because you're moving left. Okay? So, here is the answer. 3.74 times 10. That is always going to be the times 10 two part. You just told me we're going to move it in the left direction, and you were right.
So
You were correct, I should say.
Moved it 3.
How many places did we move the decimal
3.
to the left? 1, 2, 3. So therefore, 3.74 times 10 to the negative 3. Let's do another example. 1,200. Surround, if you would just put that right there, that'd be fine. Thank you, sir. So, where would I want the decimal to be?
At that end.
Between the 1 and the 2. Now, even though you don't see 1, this number is 1,200, right? So where is there an implied decimal here?
Behind the 0.
Behind this 0 way out here, right? So now you're moving to the In order to go from the arrow where you're going to put it to where it should be, you're moving to the right. and that is 1, 2, 3. Now, sig figs. Can't lose them. So this is 1.200 times 10 to the third. I know these zeros are going to be a struggle right now.
We're not
until I teach you significant figures. Hi.
If we're not doing significant figures yet, why do we have to do them?
We're going to do them eventually. So I'm kind of just laying some groundwork for the future.
Okay.
Let's do one more before I hit stop. 4,063.89. Where would I want it? Between the 4 and the 0, right? So to get it where it goes, right or left? To the right. And how many places? Just kind of works out that it keeps me in 3, and I'm bummed about that a little bit. So this ends up being 4.06389 times 10 to the positive 3. Let's do a hard one. Yeah.
0, 7, 12, 1.
Let's do a hard one.
Times 10 to the 12.
Hey, Mr. Gerbe, it's at 6.
That's okay. I'm going to go to 7 minutes. I'm going to do one more
Yeah,
example, and then I'll stop.
That's right.
Thank you, sir. So 175.1 times 10 to the third. First of all, is this an accurately written scientific notation? No, it violates this. Here's the bummer about it. You gotta pull it out and then put it back in. Okay? So, what does this 10 to the third mean you're gonna do with that decimal? 3 to the
Right.
right, because it's positive. So this number becomes 175.1, and how many zeros?
2.
2 more. Because you would move it 1 to the right, 2, 3. So now you have your decimal there. Now, put it back in scientific notation. Where do you want the decimal?
1 and 7.
Between the 1 and the 7. So, in order to get it to there, you're moving to the
Right.
to go from your arrow
left.
to the decimal.
Left.
Moving to the
Right.
right.
Right. Yeah.
And how many places?
5.
1, 2, 3, 4, 5. So this answer, width, is 1.7510 times 10 to the
5.
fifth. Now, I would have accepted 1.751 times 10 to the fifth as well, because technically you didn't have those zeros when you were up here. Would you hit the red button to stop the record, please?